Hello guys, let's prove this implicit differentiation, which says if square root of y over x plus square root of x over y is equals to 6, prove that dy over dx is equals to x minus 17y divided by 17x minus y. One of the common mistakes that I've seen among students is that they start directly with dy over dx of this function and they never land up with this answer, which is quite frustrating. So guys, it's important that you simplify this function before you even differentiate. You might have noticed square root on the question, but there is no square root on the answer. So first thing first, we need to remove this square root from the question. To do so, square on both sides of the equation. On this side, it becomes a plus b whole square, which is equals to a square plus b square plus 2 times ab, which you might have learned in the lower classes. So let this be a and let this be b. So let's use this formula to expand this one. A square means square root of y over x whole square plus b square means square root of x over y whole square plus 2 times a is y over x times b is x over y, which is equals to 6 square means 36 on the other side. Exponent 2 and square root get cancelled out, which becomes y over x plus x over y plus 2 times square root of, I can bring these two separate expression under the same square root. I can say y over x times x over y. This gets cancelled out, which becomes 1 inside the square root. So y over x plus x over y plus 2 equals to 36. Take this 2 on the other side, which becomes y over x plus x over y equals to 36 minus 2. 36 minus 2 is 34. So y over x plus x over y is equals to 34. Guys, we are still simplifying this function and we are yet to differentiate. Now I want to make the common denominator here. I want to multiply y to this x and I have to multiply same thing in the numerator, and I want to multiply x to this y and I have to multiply same thing in the numerator. Now you see it has become a common denominator, that is x times y means xy and y times x also means xy. So I can write this in a single fraction now. Y times y means y square plus x times x means x square divided by xy, which is equals to 34. Now I want to take this xy on the other side of the equation by multiplying xy on both sides of the equation. Now it becomes y square plus x square divided by xy times xy equals to 34 times xy. Xy and xy get cancelled out, which becomes y square plus x square equals to 34 times xy. So guys, now only I want to differentiate this function, so I perfectly land with this answer. Now let's differentiate this with respect to x on both sides of the equation. Differentiation of y square means bring this exponent 2 in the front, that is 2y, subtract 1 from the exponent, and then you differentiate this base, that is y, d over dx of y, plus differentiation of x square means bring this exponent 2 in the front, that is 2, and subtract 1 from the exponent 2 minus 1, and then you differentiate the base, that is x, equals to write 34 separately because this is the coefficient of xy. And now you differentiate this x times y, which follows product rule of differentiation, which says d over dx of u times v, means you'll keep u as it is and differentiate v, plus v as it is and differentiate u. So in this case, x is your u and then y is your v. So follow this rule and differentiate. So that is x times differentiation of y plus y times differentiation of x. Now you simplify this further, which becomes 2y dy over dx plus 2x dx over dx means 1, which equals to 34 x times dy over dx plus y times dx over dx means 1. Since a 2 is common on this side, so take it out separately. 2 times y dy over dx plus x equals to 34x dy over dx plus y. 2 times 1 is 2 and 2 times 17 equals 34. And now you see that there is 17 in the answer part. So which means we are few steps away from the answer. Let me erase this part and let me write this on top. y dy over dx plus x equals to, distribute this 17 to both of these terms, so it becomes 17x dy over dx plus 17y. Now bring this dy over dx on this side and take this x on the other side, which becomes y dy over dx minus 17x dy over dx equals to 17y minus x. Since dy over dx is common on this side, so take it out, which becomes dy over dx bracket y minus 17x equals to 17y minus x. Divide by y minus 17x on both sides of the equation. This get cancelled out, which leaves us dy over dx is equals to 17y minus x divided by y minus 17x. dy over dx equals to, I can take minus 1 out from the numerator and it becomes minus 17y plus x. I can also take minus 1 out from the denominator, which becomes minus y plus 17x. Now minus 1 and minus 1 get cancelled out, which leaves us dy over dx is equals to x minus 17y divided by 17x minus y. So this is how we prove this implicit differentiation. Guys, I hope this video is helpful and thank you for watching.